Alright, hey geometry students, I've gotten some questions about IXL standard S.6, area and perimeter in the coordinate plane part 2. So I thought I'd create a quick video to show you what to do on these types of problems. This follows pretty closely with standard S5, area and perimeter in the coordinate plane part 1. So we're going to try to apply what we did in the last video to this video here. What's the perimeter of rectangle BCDE? Write your answer as an integer or as a decimal rounded to the nearest tenth. Well, there's a couple ways I guess you could approach this, and I'll outline those two ways again. You could approach this using the distance formula. Remember, our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's our distance formula. Now the distance formula comes from the Pythagorean theorem, so we can also potentially, and in most cases, apply the Pythagorean theorem. A squared plus b squared equals c squared. So take two sides of right triangles, two legs, square each one, sum them. That should equal the square of the hypotenuse. So if we could create some right triangles, I would say more often than not this is going to be the easier way to go. If you don't feel like you could create a right triangle, you should be able to. If not, though, you could use the distance formula, pick 2 points, and utilize that. I'm going to use right triangles in this case. So I'm going to create a right triangle and just try to find each side here. Now this is a rectangle, so once I find two sides, I know the opposite sides are equal length. So let's find side BE. So BE, do my best to draw a straight line. There we go. So I'm going to create a point here in the coordinate plane, and then I'm going to pull over here to point E. That's a right angle right there. And I know that the distance from B to this particular point here, let's say that's 9 units plus 3 more units, that's 12 units. And then I also know the length here is from -7 to 2, so that's 9 units there. Well, this again is a 3, 4, and this should be 5, so this should be 15 units, Pythagorean triple. If you say, how'd you get that? Well, just take 9, square it, plus 12 squared equals, we'll just call it c squared. All right, we'll call this side c. Well, that's 81 plus 144 equal to c squared. Add those together, you'll get 225. Take the square root of both sides. You get this hypotenuse is 15. So hopefully soon you'll start picking up on some of those Pythagorean triples. Well, if this is 15 units, well then this has to be 15 units. This side is opposite this particular side here. So BE, CD, those are opposite sides. In a rectangle, those opposite sides are congruent. So now let's, I don't know, let's just draw a right triangle down here to find BC. Here's where we'll stop, and then we'll draw our line over from C. Do the best we can. There we go. So the length of B to this particular point right here, let's see, that's -9 to -3, so that's 6 units. And then from C, that's 1 all the way back to -7, so that's 8 units. So let's try to find the length of BC. Another way we could write this is 6 squared plus 8 squared. You could say equals c squared again. I'm just going to say equals BC squared because that's the length of BC squared. So that's 36 plus 64. Oh, it looks like we've got another Pythagorean triple going on here. Equals BC squared. That's 100 equals BC squared. Take the square roots of both sides. So BC equals 10. So that's 10 units here. 10 units here. What's the perimeter? That's what we want right here, just reviewing what the question is. We want the perimeter. I'll write that over here. We want 15 times 2 plus 10 times 2. So that gives us 30. Let's see if I can get that 2 on there. So that gives us 30 plus 20, 50 units. The perimeter of this rectangle is 50 units. Let's type that in. Hit enter. Got it. Fantastic. All right, let's get rid of those annotations. Same idea here, perimeter. I would create some right triangles. Honestly, I think that's going to be the easiest way to go about this. You can use the distance formula if you like it, but I kind of like, when I have a coordinate plane in front of me, I like creating right triangles using Pythagorean theorem. Let's jump a level. Let's see what else we've got going on here. They want the area and they want us to graph the square. So let's graph this together. Square ABCD with vertices A2, -3. So there's A. B2, -1. So 2, -1. C, 0, -1. So there's C. And D, 0, -3. So we got our square, A, B, C, D. They want us to find the area of this square. Well, what's the area of the square? It's just going to be, being it's a square, it's just going to be the length of any side squared. Well, what's the length of a side here? The length of any given side is 2 units. So what's the area of this square? Well, it's going to be side squared. So the area in this case is 2 squared, which is 4 square units. Okay, so the area of this square is 4 square units. Let's scroll down. Fantastic. We got it. We got it. Let's get rid of the annotations. What's the area of triangle DEF? Well, we haven't done a triangle yet, so let's try to figure this guy out. So to find the area of a triangle, you got to remember your area of a triangle formula. And all the formulas that would have been given to you on the end of course test, Georgia DOE geometry formula sheet. Here it is right here from the Georgia Department of Education. How do we find the area of a triangle? I'm going to zoom in for you. It's right there. Area is 1/2 base times height. So if we can find the length of the base and the length of the height, or how tall this triangle is, we'll be in good shape. So I'm going to be using the area formula for a triangle. Area is 1/2 base times height. Well, the base is the distance from E to F. So that's the distance from -7, x value, -7, to an x value of 1. That's 8 units. Okay, so the base here, the base is 8. So 1/2 times 8 times the height. What's the height of this triangle? We'll drop a perpendicular from the top point all the way down to your base. I know this is not a straight line, but we're going to do our best. Boom, perpendicular right there. That's our height. The height of this triangle runs from -9 all the way up to 10. That's 19 units. 19 units. So the area is 1/2, 8 times 9. Well, 1/2 times 8, that's 4. And that's times 19, excuse me, times 19. What's 4 times 19? I don't know, you guys give me that real quick. What is that? 76 units squared. If you don't believe me, another resource you can check into, go to desmos.com/scientific. Get rid of the annotations for just a second. And you could type in 1/2 times 8 times 19. Look at that, 76. We're on the right track. Good work. So there's the annotations there. 76 is the area of this triangle. I'm going to scroll down. 76 square units. Super. Fantastic. Off. All right, here's an additional problem I pulled off of IXL. What's the perimeter of this quadrilateral CDEF? We're going to have to use the same techniques that we've been using. We're going to need to create right triangles. So I'm going to show you a couple of those right triangles real quick. So there's one right there. Here's a right triangle. We'll go ahead and put this right triangle up here. We've got a right triangle down here. And then we've got a right triangle here to find the length of segment CF. So basically you got a bunch of right triangles. You're going to try to find the values of these hypotenuses, and we're going to go from there. I'm going to pause this real quick. I'm going to put the work on the page, and then we'll go over it. Okay, so I've got all the sides labeled. I've got my work over here color-coded based upon my underlined lengths, and I've found the length of DE, CF, DC, and EF. What I would do to find the perimeter of this quadrilateral is I would add all of these guys up. So what I would do is pull out a calculator like my Desmos graphing calculator right here, type those in, and that's not square root of 60 there, that should be square root of 80. Enter. My perimeter is 41.5. So the perimeter of this quadrilateral that I've got right here, I pulled this one off of IXL, is 41.5 units. So that would be the answer down here, 41.5, rounded to the nearest tenth. Alright, so that does it for this video. I hope this helps you get through standard S6 on IXL. Send me an email or a remind message if you need any help, and I'll be here to help you. Talk to you later.